All right, guys, section 4, solving compound inequalities. So before we solved absolute value equations with two cases. Now we're going to solve compound inequalities containing the word and graph their solution set, and the word or and graph their solution set. So be very careful. The word and the word or mean very specific things in these problems. Okay, now these are related to absolute value equations in the sense that we had to do two separate cases. Okay, we're not really going to get into absolute value in this section for these problems, but it's related to absolute value because with absolute value you had to do two different cases. So compound inequality, intersection, and union are our vocabulary terms. So to ride certain roller coasters, you must be at least 52 inches tall and your height cannot exceed 72 inches. If h represents the height of a rider, we can write two inequalities that represent this situation. At least 52 is h is greater than or equal to 52, and cannot exceed 72 is h is less than or equal to 72. Now, both of them are true up to certain points. For example, h is greater than 52 inches means you have to be more than 52 inches or more. So if you were 300 inches, technically that would work. But you also have the restriction that you can't be greater than 72. So this one, your height has to be less than or equal to 72 inches. Again, 3 inches, if you were 3 inches tall, I know nobody's 3 inches tall, but just bear with me for a minute. 3 inches would be technically less than or equal to 72, but it breaks the other requirement. So we can write this as a combined or compound inequality by thinking of it as that h has to be greater than 52, greater than or equal to 52, and h has to be less than or equal to 72. So we write it like this. 52 is less than or equal to h is less than or equal to 72. So when you see an inequality symbol set up like this, or a statement set up like this, you would read this: h is greater than or equal to 52 and h is less than or equal to 72. Okay, so when considered together, the two inequalities like those form a compound inequality. A compound inequality containing and is true only if both inequalities are true. And the graph is where the graph of the two inequalities overlap, and we call that the intersection because that's where the two of them overlap. Okay? The intersection can be found by graphing each inequality, then determining where the graphs intersect. Okay, so if I graph x is greater than or equal to 3, and I graph x is less than 7, so I have, for the 3 one, I have a closed circle on 3, everything above it. For the 7, I have an open circle on 7, everything below it. And then the compound inequality, x is greater than or equal to 3 and less than 7 is where they overlap. And notice the endpoints follow the symbols on the statement. So closed circle on 3, open circle on 7, and everything in between. Okay, so that statement can be read as x is greater than or equal to 3 and less than 7, or x is between 3 and 7, including 3. So let's solve this and then graph the solution set. So first express this inequality. So x minus 3 is greater than or equal to -2 and x minus 3 is less than 4. Then solve each inequality. So I write them separately. Notice the x minus 3 goes with the less than or equal to -2, and it also goes with the less than 4. So for this one, I would add 3 to both sides, and same thing with this one. And out here I would have 1 is less than or equal to x, and this one would be x is less than 7. So the solution set is x such that x is greater than or equal to 1 and less than or equal to 7. Now if we graph it, so graph this one first, which 1 less than or equal to x is the same as x greater than or equal to 1. So close circle on 1, shade everything above it. Then we can graph x as less than 7, so open circle on 7, everything below. And then I graph the overlap part. Well, it overlaps between 1 and 7, including 1. Okay? All right, so here's 2 for you to try. Go ahead and pause the video. Okay, we're back. So the first one, we're going to add 3 to both sides of each one. So this would be y is greater than or equal to negative 8, and this would be y is less than or equal to negative 5. So if I have negative 8, close circle everything above it. And then if I have negative 5, close circle everything below it. Then close circle on negative 8 and negative 5. And the overlap part is in between them. Okay, so we're good there. This one, I would do 6 is less than or equal to r plus 7, and r plus 7 is less than 10. So in both cases, I'm going to subtract 7 from both sides. Those cancel. And I have negative 1 is less than or equal to r, and r is less than 3. So the first one, here's negative 1. Close circle, and r is greater than negative 1, so right there. And this one is open circle on 3, and everything below it, that's 3. So then putting them together, you'd have a closed circle on negative 1, open circle on 3, and everything in between. So if we go back to 1a, the solution would be y such that y is less than or equal to negative 5, greater than or equal to negative 8. The little braces. For this other one that we did, you would have r less than 3, greater than or equal to negative 1. And then put your set in braces like that. Okay? Pretty cool stuff. I like it. All right, guys, that's it for this first section. Next time, we're going to get into how to graph and solve OR compound inequalities.